system design. The idea of well, we've been changing a bit our design lately because I'm sure everybody heard about this FESMA rules that tends to change the rules in terms of air treatment and hygienic aspect in general. And the idea is to not have a corrective action when there is contamination, but to have an action before in the design and to have a design that will avoid contamination. So preventing rather than curing. Just a brief introduction. Dualtemp Clauger is a more than 45 years old company. We have 1,100 employees, about $250 million of turnover, and 3,000 customers. We are present. The company was originally working in the dairy industry, in the cheese industry. The area where the company comes from in France is Lyon, because you maybe didn't notice, but I have a slight French accent in French, although I'm based here in Chicago. So the company where we come from is the Alpes Mountains in France, and it's a strong cheese area, a bit like Wisconsin for the US. So the company really started from the early age to work with this industry, and because of the lack of equipment that were available on the market, we started to design and manufacture our own equipment. The company is present, of course, in the US and also in 90 other countries. Just in the US, we have about 150 people with an office in Chicago and here nearby in Milwaukee. For the air treatment system, so the idea is to have a system that is washable, that is accessible. So what is the system is made of an air conditioner, of course, which is this kind of unit in that case, which has a coil inside, fan, etc. And then we have a distribution system. In that case, it's a duct. We have the probes, of course, for temperature measurement, humidity, etc. We need also to take into consideration the airflow management, and for that, the makeup air. It's important for the air conditioner to be accessible and washable. That's what we're going to see after. The coils can be with fins or without fins, and the air distribution can be direct, or like in that case with textile duct. And the makeup air has two purposes mainly. It's to keep a positive pressure in the room to avoid outside contamination or cross-contamination between different rooms, and also to bring oxygen and control the gas levels for some type of cheese. So for all the different applications we can find in the cheese industry and even in the food industry, because we don't just work in the cheese industry, but in every food industry, we've been developing a very wide range of equipment in stainless steel. So we have floor-mounted equipment, we have ceiling-mounted equipment, different shapes. You see square, round, and all these have a purpose. It really depends what we want to control in the room, the size of the room, of course, the size of the facility. So we have again a wide range of equipment. Out of this range of equipment, to answer the FESMA, we were very interested to challenge ourselves to see, because we design our equipment thinking, yeah, they're great, they're clean, they're everything, but we wanted to have the opinion of an outside company. So we asked the 3A to audit our units and our facility, and we tried to have the certification, which we did. It was a long process involving people from design, in our designing department, the workshop, even our suppliers, our subcontractors, the inspectors from 3A. They went to see everybody, asking questions, reviewing every details. We had to do some minor changes, but we're pretty happy that these 4 equipments that we submitted were all approved. And more than an equipment, it's actually really a design it's the equipment itself. How do we distribute the air? We have to trace everything we buy. Where did we buy it? Which model? Why? So it's really a whole procedure to do so. This complies with the FESMA, because FESMA is also a lot about traceability. If anything happens, we can see where it comes from, who made it, when, etc. So we have now this certification, which we are very proud. And again, it's really to answer the hygienic aspect. Within the 3A equipment that we saw, the 4 equipments, there is this one which is the biggest unit, and it's the only one we produce with integrated CIP system. So as you can see, we have some pipes going inside and the spray balls. So this one, the other equipment, you will have to open them. The drip tray flips, the door opens, you can foam gun everywhere. This one, you don't even have to do that. You can have a full CIP system with the pump and the heater already in the unit. So you just push the button and it washes. Or we can have a trolley, or it can be connected to a centralized CIP system. So that's a very neat equipment. And the choice of the material, of course, is important, because if we sanitize, the equipment shouldn't rust. It should be compatible with cleaning equipment and sanitation. So that's all the kind of points that we really have to be careful when we build equipment for the food industry, and make sure that we will not generate contamination with our equipment. Apart from stainless steel units that are inside the process area, we also have units that are outside of the process area. These are the makeup air units. The design is a bit different, but the idea is always the same. We have slopes inside, make sure that there is no water retention, because we know that when there is water, bacteria will start to grow, and that's when the contamination starts to occur. So, and these units are kept out of the process area. Why? Because they have filters inside, and all the units that are in the process area, we should be able to wash them completely, and obviously we cannot wash a filter. At least not a MERV 14 or MERV 13 filter. So these are outside the processing area. We have in those units the EcoCTA, so it's also something that we've been working on and that we developed. The idea was really to somehow reinvent the wheel, or reinvent the makeup air handling units. Air handling units are always square, and we were like, why are they square? And we took a white paper and we said, what are the problems? You know, the problems in a square unit is you have angles. Angles can mean dead spots where bacteria can start to grow, a bit hard to clean. So we started to think, if it was round, it would be easier to collect the water, to avoid water retention. It would be easier to clean. So we started to design that, and it's a product that is very highly hygienic. We sell a lot of them in the food industry, because it solves a lot of problems that food manufacturers had before. The choice, of course, of the plastic also is obviously it's plastic, so it doesn't rust. That's also one problem solved. It's a food graded plastic, resistant also to sanitation products. So really, it's a product again that was really thought on how can we minimize the risk of contamination. So now the airflow management is part also of the design to have a good food graded design. Like I was saying in the introduction, the airflow management has two purposes: to avoid outside contaminants to come in, and also to bring oxygen to the food. So talking just about the contamination, it's if you have contamination, as it says, there will be an alteration of the aspect of your product. The flavor can be affected, of course, and reduction of shelf life. Clients, of course, if they open their cheese or their product and they see, black spots or blue, or they will not like it, or foam on it. And then you have the pathogen contamination, which is even worse, because in that case, we're talking about food poisoning and sanitary crisis. So airflow management is one of the key also to avoid contamination. The airflow management is in fact a cascade of pressure between rooms. So you normally have to start by qualifying your rooms. You have to think, okay, in my process, which room is the most critical, or the one that I want to keep the safest and the cleanest. So you have to, like that, check all the rooms and start to build like some kind of a map like that and say, that's my most critical room. For example, here we said it's the production area, so it's my plus, plus, plus. And then other rooms are plus, plus, and plus. And obviously the hallway or the cleaning areas or your docks where it's open to the outside will be really less important here. So your minus. So when you have that, you can start to say, okay, I need to put more makeup air in my plus plus, a little less in my plus, etc. And then you start to manage your airflow in the room. I will go quickly because time is flying. So to do that, again, to answer this problem, or you know that I'm sure all of you who have a facility, maybe you know that makeup air is expensive. Makeup air is energy. You have to take it cold in winter, warm in summer, and bring it to your room temperature. So we developed a system also to try to minimize the amount of makeup air, while we still guarantee, but at the same time we still guarantee this cascade of pressure. So how do we control normally the pressure between rooms in a facility? We measure pressures, obviously, and but the sensors, we're talking about something like, for example, if you want to give about 0.04 inch of water gauge between two rooms, it means if you have, for example, openings with conveyors, you will need about 5 feet per second. The air will have to go about 5 feet. That's a lot of air, especially if you have big conveyors. So we thought, instead of controlling the pressure, if we could control that air velocity, then maybe we can reduce from 5 feet per second to 0.5 feet per second. And that's what this device is doing. So you can divide your makeup air that is needed by 10. So the size of the equipment is smaller, the makeup air is smaller, the energy you consume is smaller, etc., etc. So that's a very interesting product. Again, it's linked to quality. We guarantee the quality and the safety of your product, but consuming less energy. After, just as a general keynote, we also work in refrigeration, installation audit, other problems, so COV, VOC treatment, service optimization, etc. So as a quick conclusion, when you want to design an hygienic system, you really have to look at all the aspects, the design and construction of the unit itself, with the choice of the material, the accessibility, so it can be inspected and it can be clean, obviously, maintain a positive pressure in the rooms that needs to be in a positive pressure that are critical, and the location of your equipment, etc. 15 minutes are shorter than I thought. So thank you for your presence, and if you have questions, I think we still have 1 minute and a half.